Okay. So today, we're going to deal with the derivatives of the inverse trig functions. You've had polynomial functions, which you know already. You've had trig functions. You've had exponential functions, right? Now, let's go inverse trig. And basically, what we're talking about is the following. Let's start with y equals the sine of x. Well, you say, okay, that's the trig function. Well, let's make this an inverse trig function. So the inverse is what? X equals the sine of y. That's the inverse of this, right? And then to solve that, of course, we do y equals the inverse sine of x. This is what you learned back in pre-calculus and in trigonometry, right? And so the question becomes, how do we differentiate? Okay? And it's actually a clever little use of the Pythagorean theorem here that's going to help us. And some books show this proof and some don't. I'm not sure if yours does. But let me show you this clever little use of the Pythagorean theorem. I'm going to put a star right here at this step. So from the star, find dy dx. Okay, we can do that, right? From the star, find dy dx. Okay, so with respect to x, the derivative of x, so we start, I'll just rewrite it here, x equals sine y. There would be 1 cos y, but now since I'm differentiating with respect to x, chain rule kids, implicit differentiation kids, right? Times dy dx. Okay, so let's solve for dy dx, 1 over cos y. Well, that seems kind of a weird expression. Don't I want this in terms of x? And the answer is, of course I do. But let's see here. Wait a minute. I know something. And I'm going to draw a little right triangle. What do I know? I know that if I put y here, right, I know that the sine of y equals x. What is the sine, geometry kids? Opposite over hypotenuse, right? Opposite over hypotenuse. The sine of y equals x. Let's just make that clear. So what is the third side then? Pythagorean theorem, 1 minus x squared. Oh. So then dy dx is 1 over cos y. What's the cos of y? Root 1 minus x squared over 1. Isn't this the most, I find this the most clever of all of our little proofs. That's inverse sine of x. Box number 1. I think that's this proof is so clever. Because who would have thought to come up with this? You know, and why do we do this? Well, you sort of get to this point right here, and you're like, okay, well, what do I do with that? I mean, that's correct, and I could leave it there, but I want to have my derivative in terms of x. And so I sort of use what I know about x. I know that x is the sine of y. Oh, and the sine of y is the opposite over hypotenuse. Okay. Let's follow that same method for cosine. All right, now I'm going to pull this board over. Now let's see if we can do cosine. So let's start with y equals cosine x. change that to x equals cosine y. Uh-oh, there's our asterisk step, which gives me y equals the inverse cos of x. So this is what I'm looking to differentiate. Okay, I'll leave kind of this right there so you can see the template for the solution. But let's think about how this will solve. From the starred step. Okay, let's put a line here. X equals cos y. Let's do our derivative with respect to x. So pause the video, see if you can do the derivative. 1 equals negative sine y dy dx, or dy dx equals negative 1 over sine of y. Well, wait a minute. Now I'm right back here at the equivalent step to the previous problem, and the next thing we did was we drew a right triangle, right? So let's do that here. In fact, now I can cover that up. Y. What do we know about y? We know the cos of y is x over 1. So what's the cos? The adjacent over the hypotenuse. Ah, x. Missing side, 1 minus x squared. We go back to our dy dx, dy dx equals. So we're going to say dy dx equals negative 1 over the sine of y, which is root 1 minus x squared. Y equals the inverse of x. Equation number 2. So let's just be clear here. Derivative of inverse sine, root 1 minus x squared. Derivative of inverse cos, negative 1 over root 1 minus x squared. Sorry, derivative of the inverse sine is 1 over root 1 minus x squared. Derivative of the inverse cos is negative 1 over root 1 minus x squared. These are pretty cool. This is a really cool little proof. Now, guess what you're going to do? You're going to pause the video, and you're going to do y equals tan x, x equals tan y, y equals the inverse tan of x. Find that derivative. So let's start with x equals tan y. We will now pause the video, and you will. Okay, so now we have x equals tan y. Well, let's follow our previous plan. Take the derivative with respect to x. 1 secant squared y dy dx. Solve for dy dx, 1 over secant squared y, which, since I successfully passed trigonometry, 1 over secant squared y equals cos squared y. Fine. But now let's say I want to represent this in terms of x. Well, let's do it. Here's our right triangle. All right. And then we say, okay, x equals tan y. So tan y is x over 1, opposite over adjacent, which gives us root 1 plus x squared for the hypotenuse. So the cos of y is the adjacent over the hypotenuse. So we're going to say dy dx equals 1 over root 1 plus x squared squared, or dy dx is 1 over 1 plus x squared, or y equals the inverse tan of x. And those are your 3 inverse trig proofs. Lovely little proofs and lovely little uses, by the way, of the most important theorem in all of mathematics, the Pythagorean.